Hello everybody, welcome to physics this morning. We're talking about projectile motion still, and this would be the next part of the notes, which we're going to do a soccer punt lab. We're going to go out and kick the soccer ball. Remember we did that before? And you can tell me how fast it was going? That was just y direction stuff though, right? So now you're going to actually be able to tell me the actual velocity of the ball, because we're going to be able to put these two things together, the y and the x velocity. So that's kind of the main goal. Projectile motion, so assumptions we have to make. Little g, or acceleration due to gravity, has a magnitude of 9.8 meters per second. But we are using 10 meters per second squared for our math. And it's always downward. So, maybe you learned negative 9.8 in your last science class. But now you need to know that if you're on the equator, downward is upward 12 hours later. So the negative is not necessarily the right way to do it. The effect of air resistance we're not talking about at this point, so that can be ignored. And that would, slow down. So if you look at, this is what we're doing. We're studying this path right here without air resistance. This path here then would be what would happen. Notice it doesn't go as high because air resistance keeps it from going that high, and it doesn't go as far because air resistance is always opposing motion. Okay? Rotation of the Earth can be ignored. Okay, so that's a pretty easy one to ignore, isn't it? We never feel the Earth rotating. Okay, so let's look at this picture here. This is a real important picture. So the actual velocity is that guy right there. Let me use a little different color here. The actual velocity is that. The actual velocity is that. Actual. Oh, this one's not. Oh, there it is. Notice, how would you describe the velocity according to the path? It's on a tangent to the path, right? Tangent means that it touches the curve in only one point. Okay? And so at any instant, the instantaneous velocity of projectile motion will be in the direction of a tangent to the path at that point. Okay? So notice, the first thing you want to notice on this is the angle of the velocity is continually changing, right? Now, why does that change, you might ask yourself? Well, is the x velocity part changing? Apparently not, because according to this, oh, look up there, it's all x. That must be the very instant, the highest point of the path. I did this one wrong here, it looks like. This is the actual velocity. I messed that up, sorry about that. And this guy right here is the x. Notice these x's are all the same. And we've been saying that the whole time. Now here's a diagram that says, this is right on all your physics books. The x velocity remains unchanged, regardless of what's happening in the y velocity. So if you look at the y velocity then, you can see we have our largest velocity at that point. And you can see how the x plus y, if I would draw it over here, they actually equal the actual velocity, right? It's getting smaller because there's a constant acceleration in that direction. Little dinky one. This one's all gone. And then we have a little bit bigger, a little bit bigger, a little bit bigger. Okay? So those are the vectors and the way they change throughout this projectile motion. Okay, so let's start doing some problems here. See how you do with it. Because what we've done so far has been different. Now, here's your first question. A ball is given an initial velocity of 22.7 meters per second at an angle of 66 degrees to the horizontal. Find how high the ball will go. Okay, so some of you have successfully completed the problem. Let's see how we did this. The first thing you guys would have to do is what? Well, let's see here. We have little instructions on it. Look, I have a little plan here. So number one, find the velocity in the y direction using the sine of 66, right? So kind of remember that, spell time with y, and if you're not all x's and all y's, you're not all good. So kind of the first thing you always do is get down to x's and y's. Second piece is find y, which y would be the height in this case, using v squared equals v sub naught squared plus 2ay or 2ax. Okay? You could do it differently than this. Like, in my head, I figured out how much time it would slow it down, and then took the average velocity. So, this is the math, and we end up with a 21.4 meters high. If you have questions on the math, I'll let you look it over. Okay, another way to do this is you can find time first. And you know that you're decreasing your velocity by 10 meters per second every second. So it's really easy to see that it's going to take a time of 2.27 seconds to get to the height that you're going for, right? And you know that x is your average velocity times time. And you know you start out at 22.7, you end at 0, right? So x then would be 22.7 divided by 2 for an average, times 2.27. And that would be another way you can find your height. Or another thing you could do is you could use, keep in mind, this is part of the basis of the three kinematic equations that we're studying. So this comes first. Those three equations come second. That's why we studied those for weeks beforehand. It just got erased. The other way you can do it is go x equals v sub naught t plus 1/2 at squared. Keeping in mind, x is just a variable for displacement. So in this case, you might call it y. So that'd be the height x, and then our v sub naught is 22.7 times 2.27 plus a -5 times 2.27 squared. And that gives us the exact same answer too. So there's three different ways you could do it. They're all very closely related. Okay, so those are all good questions, and I guess what it came down to is that we have to believe that the x and y parts of this act independently. There's acceleration on the y only, not on the x, so we have to split them up to do the math. So let's try this next one. It says a naval gun fires a projectile. The gun's muzzle velocity is 345 meters per second, and it's at an elevation of 32 degrees. What is the range of the shot? Okay, let's see. Oh, look. First thing is the same as before. Find the x and y. So split that vector into its components. The second thing, find time using the y velocity. Because that's what's going to determine how far in the x direction it gets to go, is the y velocity. Third thing, find x using, really it's the second kinematic equation, but there's no acceleration, so it boils down to x equals v sub naught t. The 1/2 at squared zeroes out. Okay? So there's your plan. See if you can do it. Okay, so let's look at this. Doing your trigonometry, you find your x and y velocities. Okay, so how much time? You can do this a couple ways. What we have been doing traditionally is saying that, well, 182.82 divided by 10 equals 18.285 seconds. That brings us up to the top, right? And so we know it's going to come back down. This is, it's going to come back down, and everything on the way up is the same as the way down. So we multiply that by 2, and you get 36.37 or something like that, right? Okay, now what formula did you use to do that? Well, you did this, v equals v sub naught plus 8t, and you said that your v at the top is 0, so your negative v sub naught divided by negative 10 equals t, and that's where this comes into play. You do that in your head, right? But that's only half the time. If you wanted to do it with all the time for once, then when you look at our first picture here, right here, if we look at this point right here, we can see that that y velocity, if it's on the same y plane, is equal to that y velocity but opposite magnitude. Does that make sense? Everything up is the same as everything on the way down. That's what we did last time, right? So if we look at that, we can change our formula saying that v equals, instead of v sub naught, it's just a negative v, because negative is direction. So we see the numbers the same, and then we can go plus AT, then we have 2v divided by a equals t, and then we'll get the full time. That way, you can see the math is exactly the same. It doesn't matter how you do it. You can do it either way. This is the more common way, because as the problems get harder, it's less than starting and stopping on the same y plane. Okay, so with that said, we figured out our time to be around 36.37 seconds. So now we know that, our x equals average velocity times time. And if this is the final velocity with no acceleration, or the initial velocity with no acceleration, that is the average velocity. So x then equals velocity in the x direction times 36.37, and that number fills in right there. And we should see then that our answer is 10,698. Okay? Any questions on that? Okay, so we have one more question to do. And this one then is exactly what we did before, but now I'm asking you to find the angle too. So it says a punter has a hang time of 4.5 seconds. So you know what hang time means. That's all the time it's in the air. So that's the whole time going up and going down. If the ball travels down the field 48 meters, what was the angle of the kick? Okay, so try to figure that one out. Some of you are wondering where to start. Well, I'll see what kind of plan I have here for you. Okay, it says plan. Find the velocity in the x direction using the just the displacement here. The displacement and the time. So that's already given to you. So you can find the x velocity just using that. Okay? Number 2 says, find the y velocity using Vy, or V equals V sub naught plus AT. And this, I'm saying here, as if we were dropping the ball, you must use half the total time. Now, if you did the way where you put V equals a negative V plus AT, knowing that the velocity magnitudes are the same, but directions are opposite, like I showed in the last example, you could use the full time. Okay, so let's see if you guys can go ahead and do this. Okay, so let's see how that worked out for everybody. .7 meters per second, just 40 meters here, divided by 4.5 seconds. That gives us our x velocity. So we could put that in right here. That's our x velocity, 10.7 meters per second. Okay. And our y velocity then, well, you can do it a couple different ways, but if you just take half of this time, 2.25, you know, right, if it takes 2.25 seconds to slow something down at a rate of 10 meters every second, you should be able to know that, hey, that must have been 22.5 meters per second for your velocity. Okay? So that is going to be 22.5 meters per second. Okay, and if you want to look at the math on that, that's going to be right here. Okay? And then you just take your tangent function and you put your opposite over your adjacent and you push the inverse tangent button, you should come up with 64.6 degrees, and the best label for that would be above the horizon. Do you have questions on that? Okay, hopefully that helps you finish your homework for tomorrow.